All right, so I asked you to do these problems right here kind of as warm-up. And so, what is the first thing that you did on this one right here? Somebody walk me through it. What did you do first?
Subtracted 15.
Subtracted what?
15.
Okay, 15. So subtract 15, subtract 15. Now, that's perfectly fine. That's not how I like to do it. I'll show you why here in a second, okay? But you can get that 100% right. You just got to be careful.
But you're saying you would have done plus 3?
I like to do the variables first. I want to put the variables on the side first. The reason for that is this. So if I do minus 15, I get 4p equals 7p, and that's minus 18, correct? All right, so that's what you would have gotten. Now, by the way, you might not have done it this way, and that's okay, all right? But now, I got to get the p's together, and which way do I have to move them now?
To the left.
I have to move them to the left because I don't want everything over on one side with nothing on the other side. I'm not balancing the equation, all right? So now that kind of forces me into saying minus 7p minus 7p. So those are gone. Gives me negative 18 equals negative 3p, and I divide by negative 3 and divide by negative 3. Okay? So p is going to equal to 6 is what you should have gotten there. Okay? And again, that's not the only way that you could have done it. You could have done it a bunch of different ways. Okay? Good? All right. On the next one, what's the first step that you took?
Combine
Combine like terms. These are the like terms on that side. So 6y plus 28 equals, these two go together on that side, so 9y minus 20. Okay? And again, the way that I like to teach it is I see two different variables. All right? I want to get the two variables together, so I get my pick as I'm going. All right? And so minus 6y minus 6y. We have 28 equals 3y minus 20, and I would add 20. And so I end up with 48 equals 3y, and when I divide by 3 there, what'd you come up with? 16. That is the correct answer there. Again, I can double check my work, go plug that back in, make sure I got that as I'm going along. Okay? Everybody good? Just kind of getting us back up to speed from where we were yesterday. All right. Today, the first thing that we're going to discuss today is we're going to talk about literal equations. Anybody ever heard that term before? Literal equations. All right, got a couple. All right. Anybody got a definition of that? What is a literal equation? Can't remember. You've heard it, but forgotten what it is. Okay.
No.
Is it like a word problem?
Kind of like a word problem. Not quite. That makes sense though, because literal it kind of sounds like words, right? Like a lot of letters, yeah, it's like formulas is what it is, okay? So we have formulas, and so we've got a lot of different variables in there. So literal equations are equations with several different variables, got a lot of variables. If you think back to geometry, some of you may not want to, some of you may have liked geometry, some of you may not have, but if you think back to geometry, there's a lot of formulas and there's a lot of variables, correct?
Yes, sir.
All right? And so, you might have had, like the area of a rectangle. Area equals length times width. That would be a literal equation. It's a formula, okay? So forth. So here's the first one that we have up here. By the way, anybody recognize what that equation is? What that formula is? X plus by equals C. All right? We're going to talk more about it in a minute. That's the standard form of a linear equation. Okay? That's standard form. Now, on this one right here, it's asking me to solve for y. It's asking me to get the y by itself. So if I was going to get the y by itself, here's the y. What would be the first move that you would make? What's the first thing that we did yesterday? Get rid of what? Get rid of the AX. Now, it doesn't look like a number like it was yesterday, but we've got to get rid of the addition and subtraction, which is this one. So I'm going to subtract AX from both sides. So I'm going to subtract AX. So this is gone. I'm left with BY equals C minus AX. Are these like terms, C and AX? They don't look very much alike, do they? Okay? So that's the best that I can do. Just say C minus AX. Now, I almost have the Y by itself. What's the last step?
Gotta subtract that B.
Subtract the B,
Both sides.
divide by the B. Because what am I doing? What's happening with the B here? I'm multiplying it. I do have to get rid of it. I'm going to divide by that B. So I'm going to divide by B here, and I'm going to divide by B there. So one way that you could write me this answer is you could write that answer like that. Y equals C minus AX divided by B. I know a lot of you are thinking that you're like, yuck, that doesn't look very pretty. I agree. It's not very simple. Okay? But that's what I would do. Now, once you start telling me what A is equal to, and you start filling in all the numbers, then it makes it a little bit easier. But for right now, that's the best way that I could represent that. Okay? Now, there is one other way I could write this, and I just want to show it to you just real quick because I'm going to give you the reason why here in a second. So I have to divide by B, so I divide this side by B, I divide that side by B. Another way of thinking about it is if I divide one thing by B, I've got to divide everything by B. Correct? You got to keep them all the same. So if I divided by B, B divided by B would be 1Y. C divided by B would be C over B. And AX divided by B would be AX divided by B. Okay? So this is the other way of writing it. All right? If it is a free response question where you can write whatever the answer is, fill in the blank kind of deal, I'm lazy, that's the easy answer. Correct? That was pretty easy to write. But sometimes on a multiple choice question, they might write it like this or they may write it like this. So I need to know the connection. Both of them won't be there, but this one could be the one that may be listed on a multiple choice question. All right, everybody okay with that? Now there's another reason for that here in a second. I'll bring that to your attention in a minute as well. Good?
Yes.
All right. Anybody recognize this problem right here? Okay, slope, intercept, form. All right. That's slope, intercept, form. We have the slope in there. So y equals mx plus b. All right. And it's asking me to solve for the m in this problem. So I want to get the m by itself. I want to solve for the slope. So what would be my first move? Subtract the b from both sides. That's correct. Good, Jonathan. So y minus b is equal to, actually let me do this real quick. I was doing it in a shortcut. I'm going to write it all out for you. All right. So I'm going to subtract b on this side, subtract b on that side. So I'm going to go y minus b is equal to, those b's cancel, and it leaves me with mx. Okay. What would be the next thing I could do? Trying to get m by itself, so I'm trying to get the m to be here. I need to get rid of the x. How do I get rid of the x? Divide by x. So I'm going to divide by x on this side, divide by x over here. So y minus b divided by x is equal to m. That would be kind of the easiest way to write that one there. Okay? Everybody all right with that? Did we do the same thing that we did yesterday? It's the same steps, right? But we don't like it as much, okay? But there's a lot of times it's very beneficial. If I'm trying to solve for slope all the time, then I can write a little formula right here, and as long as you give me the y, b, and the x, then I can give the answer pretty quick, right? So that'd be kind of the reason why we would do that. Okay? All right. Let's keep going. Next. All right, I'm going to get you to write down. You probably want to copy down these tables real quick. All right? I'll give you a little chance to get those in your notes, then we're going to discuss them. All right. So as you're copying this down, we want to talk about a linear function makes a line. Okay. And we want to look and see here if these points right here that were given, if they are aligned. And we're going to determine the slope there. That's going to help us to determine if it's a linear function or not. So let's have a little side discussion real quick. Let's talk about the word slope, all right? Think back to Algebra 1, think back to some geometry. When I say slope, what are some of the thoughts and ideas that come to your mind when we talk about slope? A graph, okay? What about a graph? How do we find slope off of a graph? Rise over run. We use rise over run a lot to find slope on a graph. So that's kind of some words that we can use to connect slope. How else, or what other words or equations that you may have come up with to talk about slope? Very nice. Good. Y2 minus Y1 over X2 minus X1. Some of you may be going, no, I thought it was the other way around. Y1 minus Y2, it doesn't matter, okay? As long as this is a point right here and this is a point right here, all right? I'll prove that to you later. We're going to do a problem like that. We're not going to get to it today, but we'll talk about it maybe on Monday, okay? And so that's good, all right? The concept here, the idea here, you may have heard change in Y over change in X. And that's what that formula is doing. Change in Y over change in X. So these are all just ideas, all connected, kind of talking about the same idea. Anybody have another one? We refer to slope. It's got a long word that we don't like to use a lot. Or phrase, I should say. Constant rate of change. Okay? Constant rate of change. So if it's a constant rate of change, it's the same thing, it's the same change over and over and over again. Okay? Now, I'm going to give you another term just real quick because it's IB. All right? Some of you are, this is pre-IB, some of you are headed to IB next year, hopefully. All right? But IB doesn't use the term slope. They like to use the term gradient. All right?
Yeah, I heard that.
All right? You've heard of that before? Gradient? You ever been like maybe in the mountains driving or something like that and they're like, hey, look out, steep grade ahead or steep gradient ahead or whatever. So they got these signs like, I want you to slow down and be careful. Okay? And so if you were to see the term gradient, it's saying, hey, go find slope. Okay? All right. So let's discuss the table that you wrote down. We've got x and we've got f of x. F of x is a fancy way of saying what? Y. Okay? So we have y there. So how are my y's changing in this table?
They're decreasing by 1.
Decreasing by 1. So minus 1, minus 1, minus 1. Does that look like a constant rate of change?
Yes.
Yes, but we have to match it with the x's as well. All right? What are the x's doing?
Plus 2,
Plus 2, plus 2, plus 2. All right? So is this a constant rate of change? Yes, it is. So it's going down 1 over 2 every time. And so since it's a constant rate of change, that is my slope. And that means that that is a linear function. That is a line that we see there. So if it's got a constant rate of change, we can find the slope and we can say that it's linear. Okay? There's a lot of times I get impatient, all right? And I don't like to take baby steps. I like to take big steps. So if I took a big step from there to there and from there to there, okay? What's the rate of change from there to there?
minus 3.
Minus 3. What's the rate of change from there to there?
Plus 6.
Is that still the same thing?
Yeah.
Okay, I just took big steps, right? But I'm still headed in the same direction. I'm still going the same slope. Okay? Everybody good with that?
Yeah.
All right, so let's go down to the next one here. What's my rate of change here? Okay, now when we're talking linear, we're talking about addition. All right, so the first thing that I need you to look at is this. We're going plus 2, plus 4, plus 8. All right, and this is going plus 1, plus 1, plus 1. Is that a constant rate of change? The x's are constant, but the y's are not. Okay, so right now I'm going to say that this is not linear. So when we're talking linear, we're talking about addition. All right, we're trying to find addition or subtraction to get from one to the next. Now, you made the comment in the back that it's what? What'd you say? It's like constantly multiplying. So right here we have plus 1, plus 1, plus 1. That's good, but these are going times 2, times 2, times 2. All right. So if we have repeated multiplication, what is repeated multiplication? How's another way you can write repeated multiplication? Exponents. So this is technically an exponential function. Now, you don't have to worry too much about exponential functions right now. We're going to bring those in pretty soon, and we'll talk about exponential functions. All right? But right now, we're just kind of worried about slope and things as we're going. Okay? Everybody good on that?
Yes.
Good. Just kind of trying to knock some of the rust off and trying to talk through some of these as we're going. Yep. All right. So the next little thing I want to visit with you about is I want to talk with you about there's 3 forms of a linear function. There's 3 forms for a linear function. There's standard form, there's slope-intercept form, there's point-slope form. Okay? So there's 3 different versions of this as we're going. Okay? Which one do you know? Which equation do you know? Slope-intercept would probably be the one that most of us would say is probably the easiest, and we might know some of the other ones as well. Let's talk about the middle one first. So slope-intercept form. What is the equation for slope-intercept form? Y equals mx plus b. Where m is the slope and b is the y-intercept. Now be careful there. And so they probably misnamed it. They were probably being a little bit lazy, and that's okay because it's really the slope y-intercept form, right? I was going to be really technical about it. But slope-intercept form, y equals mx plus b. M is my slope, b is my y-intercept. Okay? Anybody have a remembrance of standard form or point-slope form? Yes, ma'am. Okay, what do you think? Point-slope form is what? Close. Y minus y1 equals m x minus x1. Okay? You were starting on the right spot. Okay? So we still have slope in it. All right? And then what happens here is the point that's given here, the point is x1 and y1. So it's the opposite. So if this is a negative there on the graph, it's positive. If it's a positive out here, it's a negative on the graph. So the x1 and the y1 change signs when we plug it in. Now, here's the thing. If I ask you to use one, many of you are going to shy away from using this one right here, which when I was your age, I was the same thing. I hated point-slope form when I was your age when I was in school. However, it's probably the most beneficial one that we have. We can get a lot of things handled from point-slope form just because we have. Because slope-intercept form is point-slope form, but it's a specific point. It's only the y-intercept. With point-slope form, it's any point that you could come up with and the slope. Okay? And the last one, standard form. Anybody remember standard form?
No. AX plus BY equals C.
Good. AX plus BY equals C. We kind of talked about it real quick at the beginning of the class. All right? AX plus BY equals C. Now, there's a couple little asterisks besides this one, all right? Here it is right here. For standard form, A needs to be a whole number, and B and C are integers, okay? So when we write it in a standard form, A needs to be a whole number, and B and C need to be integers, which means what kind of numbers do I not want? Decimals or fractions, right? No decimals or fractions in standard form, okay? Next question. What is the difference between a whole number and an integer? Say again? One's negative. Close. All right? One's allowed to be negative, I should say. Okay? I'm just going to change it a little bit. Because integers could be positive or negative whole numbers. Okay? So the negative is what's the difference? Whole numbers are only positive. Okay? Integers could be positive or negative. Which means A has to be what? Positive. A has to be positive. B or C could be positive or negative. Okay? Now, some people like standard form because it looks pretty. Alright? Because there's no fractions, no decimals, anything like that. But a lot of times it's not super helpful. Okay? Looks good, but not really helpful. Everybody good?
Yeah.
Alright, let's keep going. Alright. From geometry, if you were going to draw a line, what do you need to draw a line? How many? 2 points, and I can draw a line. I got a point here, got a point here, I can connect them with a line. Okay?
I'm gonna say the right.
Now, the 2 points that I think are the easiest to find are what?
The x-intercept and the y-intercept.
That's correct. I think the easiest 2 points to find on any graph would be the x-intercept and the y-intercept. Okay? Now I'm going to teach you, you may not have done this before, I'm going to show you, sometimes it's pretty easy to graph lines with intercepts. Alright? What do you know about the y-intercept?
It's on the y-axis.
It's always on the y-axis. Now, what's true about all the points on the y-axis? X is 0. For every point right here, X is 0. So if I'm going to find the y-intercept, I'm going to plug in 0 for X. So if I'm looking to find the y-intercept, I'm going to plug in 0 for X. So my point would look like that, 0 and some y value. Because 0 is my x, and then I'd get whatever y I have. If I'm going to look for the x-intercept, it's on the x-axis. What's true about everything on the x-axis?
Y is 0.
Y is 0. So I'm going to plug in 0 for y. So I would have x, 0 would be the format that my x-intercepts would look like.
Yay.
Okay? Now, I don't know about you, but do you like plugging in the number 0? You don't like plugging it in? I like it. It makes everything really easy, right? It just gets rid of things, all right? That's my favorite number to plug in. I'm going to plug in 0. I just don't like to plug zeros into my bank account. That's the only spot I don't like to plug it into. All right? Sorry. Just trying to see if you're awake. And that's late in the day. All right? So plug in 0 in. So let's try one of these. Okay? So if I were to ask you to graph this equation right here. So we're going to graph 4x minus 2y equals 16. We're going to graph 4x minus 2y equals 16. What format is this in right now? Standard form. Okay? Now, many times we're going to take and how would you handle that a lot of times?
Get the x to the other side.
You'd move the x to the other side, then you divide by 2, all right? And you put it in slope-intercept form and you do that there. Now, I'm not going to do that on this problem. I want to do it a little bit different way first, okay? So, because I'm going to do that here in a second. So, I'm going to go find the x-intercept. how do I find the x-intercept? I'm gonna cover up the y, because I'm gonna make it 0. So if I cover up the y and make it 0, I'm gonna get 4x equals 16. Is that a pretty easy problem to solve? Yep. Divide by 4, divide by 4. So x is equal to 4. 4, 0 is my x-intercept. By the way, do you have to write all that down, or could you probably do that mentally? You probably could do that mentally, all right? So 4, 0 is my x-intercept. It would be about right there on my graph. By the way, don't worry about if you're graphing right now. Just draw me a quick little sketch of it. If I want an accurate graph, I'll provide you on like a quiz or a test, a graph paper for you to put it on there and count it all out. Okay? All right. Y-intercept. I'm going to cover up the x because I'm going to make it 0. So that would give me negative 2y equals 16. I'm going to divide by negative 2. So y would equal to negative 8. So I plug in 0 for x. I got negative 8 for the y. There's that point. Could you graph the line? Yes. I can, right? Those 2 points are super easy to find, and I can graph that way. Now, how many of you were ever told to graph that way? Probably not something that you really thought about in Algebra 1, right? But that's a pretty quick, pretty easy way to graph, or to at least check your graph and to see if you're in the right direction. Okay? Everybody good? No. All right. Now let's kind of graph the way that you were probably taught in Algebra 1 or even geometry. I'll give you just a little bit of time. I think a couple of you are finishing that one up. Everybody good?
No.
Okay. All good? Good. All right. So again, I'm going to graph this equation right here. But I'm going to graph that the way that you talked about graphing that a while ago. And let's change that to slope-intercept form. So if I'm going to change this to slope-intercept form, what would be my first move? Add the 4x's to both sides. So 2y equals negative 1 plus 4x. Is the red equation, the purple equation, the same equation? What did I do? They're the same. What did I do? Just switch them. Is the 4x net positive there?
Yes.
Is it still positive here?
Yes.
Yeah. Is the negative 1 still negative there?
Yes.
Yes. Now, most of us probably prefer to see it in the purple one than the red one. Do I care? Does it matter? No, it really doesn't matter. Okay? Now, the last thing, divide by 2, divide by 2, divide by 2. Now, a while ago, Coach Rice, you just divided this side by 2 and that side by 2 because you did it the easy way. All right? This time, I divided everything by 2 because 2 divided by 2 is 1, or y. 4x divided by 2 is 2x. And negative 1 divided by 2 is negative 1/2. So now I have my mx and my b. So I have them separated. Okay? If I just divide the whole side by 2, then I don't have them separated and I don't know what the m is and what the b is. Okay? Now, if I were to do this right here, all right, what do I graph first when I go to my graph? Do I put the m or do I put the b on the graph first? B. The b is the y-intercept. I'm going to put that here. All right? So I'm going to graph the y-intercept. Now, when I do that, I graph the b first because I like to think about it as that's where I begin. All right? I'm going to graph the b. I'm going to begin the graph like that. Okay? Then, after I graph that, a lot of times I'm going to write my slope as a fraction. Because what do we say slope was? How can we do that on a graph from a while ago? Rise over run. So I'm going to count my rise of 2, my run of 1. So I'm going to count up 2, 1, 2, and run 1. I'm going to count up 2 and run 1. And then there is that line right there. So I did my B value tells me where to begin, and my M value, my slope, tells me how to move on my graph. Okay? Where to begin, then how to move. Okay? So that's kind of how I think through that as I go. I like to think of it like this as well. There's sometimes I have friends that come to town for like an Aggie football game or whatever. And you know, if you've been in town during those games, it kind of gets kind of crazy. And I get a call from time to time. They go, "Hey man, I'm lost. All right, help me out," or whatever. All right, now I know you have GPS now. This is back a long time ago or whatever. I said, "Where?" And so they say, "I'm lost." And what's my first question? Where are you? Right? Where you at? All right. Because once I know where they're at, then I can do what? Now I can tell them where to go. I can tell them. So I need to know where you're at. I need to know where you begin. Then I can give you directions on how to move, and I can get you fixed up with what's going on. All right? Make sense?
Yes, sir.
All right. Got one more problem for you, and then we're going to be finished for the day. Hang tight. Here we go. All right. Here's the last problem. Give you a chance to copy that one down. All right. This one is in which format? This is in point slope format. But many of you will automatically go, "I don't like the parentheses. I'm going to distribute and I'm going to change it to slope intercept form." All right? That's actually harder to do here than actually just the graphic from point slope form. What's the slope? Negative 2/3. What's the point? This is the only tricky thing about the point. It's going to be the opposite of what I see there. So I see a positive 2. It's actually going to be a negative 2 on my graph. I see a negative 3. It's going to be a positive 3 on my graph. That's the point that I'm going to use. So negative 2, 3. So negative 2, positive 3. That's the point. That's where I'm beginning. All right? I'm going to count down 2 and over 3. Down 2 and over 3. And there is where I'm going to be. Okay? Now, that's point slope. Was that pretty easy to graph? Yes. As opposed to distributing negative 2/3. So I have to distribute negative 2/3, and I get that right there. Then I have to add the 3 and add the 3. Does this look like it's fun to add together? No. Not really. We would have to take this 3 and multiply it by 3 and make it 9/3, because that's the same thing as 3. So now we can add them together and get 5/3. And then that's my y-intercept. Well, how about that y-intercept? That y-intercept fun to graph? Not really, right? Okay. So this is a case that point slope form would be better than slope intercept form in my opinion. Okay. Now can you still do it the other way?
Yeah.
Sure. All right. Again, there's lots of different ways to do this. Fine. All right. We took a little bit longer than I expected. We have about 5 minutes remaining. Here's what I want you to do. Grab the homework page or the assignment page. Okay? All right. Here we go. Going down the left-hand side, and then one at the top, there's 12 literal equations. I want you to pick 6. Any 6 that you want to do. Okay? So there's 12 problems right there. I want you to pick any 6 that you want to do. Okay? On the right-hand side, okay, where it says assignment 1.2, 1 through 10, I want you to either pick the evens or the odds. Okay, so 1 through 10, you're going to do the evens or the odds. So pick 6 on the left, evens or odds on the right. I shortened that assignment quite a bit, okay? And you can work a little bit right now, and we'll check that. We'll go over that on Monday after you have hopefully a good weekend. So, all right? Any questions about anything? All right.